Define the sign of acceleration for the motion on a straight line with a constant acceleration. Newton's second law states that if a force with F Newton acting on an object with mass m, it will create an acceleration a. Remember, F and A here are both vector quantity. They have magnitude and directions associated with. And F is resultant force or net force, and A is resultant acceleration. However, when we form resolving equations, we do not use F and A as vector quantity anymore. We only use F and A as algebraic values. They are just positive or negative numbers. For example, if I have equation 2 plus t equal m times 5, then 2 plus t is net force, and phi here is acceleration. However, sometimes you see people use minus 5 instead of positive 5. How do you know? The common misunderstanding that people used to think is if A is positive or if we have positive acceleration, then the object is accelerating. And if we have negative acceleration, then the object is decelerating. It's not correct, so just cross it. It is not correct. That's why I say common misunderstanding. Only the sign of A cannot tell us that the object is accelerating, speeding up, or decelerating, slowing down. We need to look at other factor. It is velocity. So what is the rule? The rule said that if the vector A and vector V is in the same direction. When I talk about vector, I always talk about direction as well. So vector A and vector V is in the same direction, then the object is accelerating. Same direction here tells us that A and V as numbers are both either positive or negative. When two numbers have same sign, so their products have to be positive. So if A times V is positive, then it is accelerating. The object is accelerating. And if vector A and vector V is in the opposite direction, then the object is decelerating. Opposite direction means that the value of A and value of V have different sign. If A is positive, then V is negative. So when two numbers have different sign, then their products have to be small zero or negative as well. Let's sum it up. If A times V is bigger than 0, then accelerating. If A times V is small 0, then decelerating. We use this principle to define the sign of acceleration for horizontal motions, and after that we use the same principle to define the sine of A for vertical motions. Now look at the horizontal motion first. We have two people running on a horizontal road starting at rest, point O. The person 1 is accelerating from left to right with acceleration 2 meters per second square. The person 2 is accelerating too, but now he is from right to left with acceleration is 3 meters per second square. Where would they be after 5 seconds? Now look at the problem. It is simple. It is easy. You don't need advanced physics knowledge to solve it. But I just want you to use this example as a chance to find the sine of A by using the rule we have learned. So the question is, where would they be after 5 seconds? Can be interpreted like, what are the positions after 5 seconds, where they are after 5 seconds. So if I have the road, horizontal road like that, they start at point O. And the person 1 from left to right, there's a person 1 from left to right. And the person 2 from right to left. That's a person 2. Okay. And we know that they are both accelerating. Now the first thing we do, we choose the origin. Origin point is O. I just choose it because it makes our lives easier, because they are both starting at O. Then we need to choose the positive direction. You can either choose left to right as positive direction or right to left as positive direction. It doesn't matter. The answers is still the same. So let's choose positive direction from left to right. If I choose direction from left to right is positive, okay? Then from right to left has to be negative. It's positive direction. I would say left to right. Now we need to define the sign of acceleration for each person. Remember, accelerating means A times V is bigger than 0. So for person 1, he is moving in the positive direction. Because we choose left to right is positive, so his V with right bigger than 0, positive. And because he is accelerating, then A times V is positive too. Those two conditions will give us that A is positive. For the person 1, he has positive acceleration. Then we can write A for person 1, instead of right, you can write positive 2. You don't need to write positive sign, but I make it like that so you can remember it. So for person 2, look at the way he moves. He's moving from right to left. And right to left is negative direction. Negative direction means this V is negative. And he is accelerating too. Then A times V has to be positive. That will give us that A has to be negative. sorry, V negative, A negative, then we have A times V is positive. So we can write acceleration for person 2 is negative 3 meters second square. Okay, so the person 2 is accelerating, but he has negative acceleration. Then now you can see how we use the product of A and V to define the sign of A. To find the position of two people after 5 seconds, then we need to plug all the information into the formula. I hope you guys still remember it, which is S equal AD squared over 2. That's the formula we are going to use. So for the person 1, we have person 1. S1 will be equal A1 times D squared over 2. A1 is 2, then 2 times D is 5 squared over 2, which gives us 25 meters. How about the person 2? For the person 2, we have S2 equal A, which is minus 3 times D squared over 2, which is 5 squared over 2, and it will give us negative 37.5 meters. We see that we have S value is negative and positive. What does positive S mean? It means the person 1 is in the positive direction. Okay, this positive direction that we know that he is on the right of the origin O, and he is 25 meters away and on the right. For the person 2, S2 equal negative 37.5, and we know that he is 37.5 meters away from the origin point O. And because we have negative of S, then he has to be in the negative direction, or he has to be on the left of O. So by using the rule, you only can find the distance and the direction for the two people.